here's our college algebra exam review with some hints on the types of problems that you'll see. Okay, so let's look at some equations. So here's an interesting equation. 3x minus 1 over 4 plus x plus 3 over 6 is 3. Now, I'm not going to ask you what the solution is. The solution, by the way, is x is equal to 3. And you could easily see that by taking 3, putting it there, and seeing what you get. 3 times 3 minus 1 over 4, and 3 plus 3 over 6 is supposed to be 3. Now let's see if that's true. This is 9 minus 1, which is 8, and 6 over 6, is that equal to 3? Sure. 2 plus 1 is 3. Okay, so that's the solution. Let's not figure out, or let's not worry about what the solution is, but how you might get it. Okay, so suppose you were actually asked to solve this. How can you go about doing that? Well, the first thing you might notice is that you got a bunch of fractions in here, and I hate fractions, so let's get rid of the fractions. Multiply both sides by a number, which will clear the fractions. Probably the best choice, looking at the 4 and the 6, is 12, because when you multiply 12 on both sides, there'll be some canceling. Let's see, on the right side, you just get 36. On the left side, when you multiply the 12 and you have the 4 down here, the 4 will go into the 12 3 times, so you have 3 times 3x minus 1. And in the second multiplication, the 6 will go into the 12 2 times, and 2 times x plus 3. Okay, so that's the way that would go if you were to do that. And again, it's probably smart just to go ahead and practice this problem a few times. Make sure you're happy with how to solve it, because I'll be asking a question about how you solve an equation like this. Again, distributing, right? So now we have 11x's plus 3 is 36. Get rid of that guy. Or 11x is equal to 33, or x is equal to 3. Okay, which we knew was the answer. So make sure you know how to solve an equation like that. Let's look at an inequality. I like this one. Hint, hint. 4 is less than or equal to minus 9x plus 5 is less than 8. I'm not going to ask you what the solution is. I mean, the solution is this interval, negative 1/3 to 1/9, right? Open on one side, closed on the other. But let's just sort of see how you get there. What would you do with this first? I would probably take 5 away from each piece. Okay, so you can always subtract, and that doesn't change anything. 4 take away 5 is minus 1. Negative 9x, and 3. Okay, now at this stage, I'm trying to get the x by itself, and we see we have negative 9 times x. Let me get rid of that for a sec. So how can we get rid of the negative 9? Well, you know, think if you had negative 9x is equal to 100. What would you do? I suppose you could do two things. You could multiply by a negative 1/9, right? Or you could divide by 9. Means the same thing. Hang on just a second. Let me put this beast on. Okay, back where we were. Let's see. Yes, we could multiply through by negative 1/9. Now, if it's an equation, that doesn't really do anything. The equal sign stays the equal sign. So negative 1/9 times negative 9 is x, and 100 times negative 1/9 would be negative 100 over 9. Now, if this were a inequality, right, then you would have to switch the sense of the inequality. So if you had negative 9x is less than 100, and you decide to multiply by negative 1/9 to get rid of the negative 9, this has to switch. Right? So you always switch when you multiply or divide by a negative. Okay, so I'll let you play with that. By the way, the next line on this would be x is greater than negative 1/3 and less than or equal to 1/9. So if you want to think about how you get from there to there. Okay, let's see. Another exam question that I sort of like a little bit on lines and midpoints. Make sure you know the midpoint formula, or if you want the average point formula, hint, hint, for finding the midpoints of segments. But how about perpendicular lines? Perpendicular lines. Okay, obviously there's something with the slopes here, not midpoints, but slopes. So let's suppose we had a line that had a slope of 5 and another line that had a slope of -1/5. These two lines would be in fact perpendicular. And what's the special relationship between -1/5 and 5? You couldn't say they're opposites. That would be wrong. Opposite means the same as negative, and these are not just negatives. Okay. You could say they're reciprocals. Well, maybe you can because they're not reciprocals. C-I-P-R-O-C-A-L. Reciprocals, no. The reciprocal of 5 is 1/5, not -1/5. So I think in last year in Algebra 2, we used the term negative reciprocals. So that's a good way to describe them. Your textbook has something, another way of looking at it, and you might want to go back and look in your textbook. What's so special when you multiply negative reciprocals? What do you get all the time? So you might want to look at that. Okay, systems of equations. Systems of equations. So we're talking lines, and I guess we have three different situations. One, you could have two lines that intersect. Okay, so that's called a consistent system. Consistent system. And there's one solution. So this is the unique, the only point, right? Only point of intersection. One solution. Okay, a second possibility would be if you had two lines that never intersected. So let's say we had two parallel lines. Slopes are the same now, right? Slopes same. So this is inconsistent system. And there's no solution. There's no point of intersection. And the third type that we ran into is where we have two lines again. Let me see if I can do this with two different colors. Suppose I had these two lines, but the blue one was actually lying right on top of the red one. Okay, so in this case, the two lines are really the same line, and these result from dependent equations. And there's actually an infinite number of solutions, which makes sense. Any point on these lines would be on both lines. Okay, so how do you know when you have one type or the other? Well, this is the one that we run into most of the time. You just get whatever the x and y coordinates are. So if this is 5 and this is 4, you'd get the ordered pair 5, 4, and somewhere when you're working it out, you would get x is 5 and y is 4. That's your consistent system, one unique solution. How about the impossible situation? Well, here, no solution. When you work this one out, you end up with some sort of a false statement. So if you ever ended up with 0 is equal to 1, that tells you it's inconsistent and there's no solution. The dependent equations, you end up with a true statement. As you try to solve this type, you would end up with a statement like 0 is equal to 0 or 1 is equal to 1, anything like that. That says you have an infinite number of solutions, and any point on the line would be legit. Okay, so look at systems of equations. Let's see. Sums of cubes, make sure you know that. We beat that a million times. How about reducing rational expressions? Here's a problem that you had at one point or another. 4x plus 1 divided by 2x minus, or times 2x minus 3 divided by 2x minus 3 times 4x plus 3. How do you reduce? How do you reduce? Okay, how do you reduce these things? So make sure you cancel common factors. That's what you have to do. That's why we learn factoring, is to be able to reduce that. Make sure you reduce it all the way to the end. Okay, what other goodies? So how about my famous -3 squared? Remember, this works out to be -9. And you're thinking, well, isn't -3 times -3 a positive 9? Certainly is. So if you had -3 times -3, that does give you 9. But with the minus sign sort of stuck out here, it does not go with the 3. Right? You have to do the exponents first, and then the minus sign just sort of appears. Where does that come into play with roots? Well, let's suppose we had negative 9 to the 1/2. So we know this is a square root, right? The roots are on the bottom, so square root of 9. And the minus sign goes out front. So we get minus 3. No problem with that. On the other hand, if we had this, this is a much more interesting situation. Now we have a square root again, but now the negative 9 is inside, not real. This is not a real number. It doesn't fall on the number line anywhere. Now, if we wanted to invent a new kind of number called an imaginary number, you could call this 3i, right? Square root of 9 is 3, and the square root of minus 1 is I. But yeah, so just be careful when you're dealing with negative signs and exponents. Quadratic formula, make sure you know that. A little bit on discriminant distance formula, make sure you know that. How about finding inverse functions? Let's suppose we had 5x, y is 5x, and your task is to find f inverse. And graph them both. How would you do that? Well, let's see. We could certainly look at some ordered pairs here. If x is 1, y is 5 times 1. If x is 2, y is 5 times 2. If x is 0, y is 5 times 0. Okay, so we have some ordered pairs, and we could graph those pretty easily. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's see. 0, 0, 1, 5. 2, 10, obviously a fairly steep line here, and the slope would be 5. Right? Rises 5, goes up 5, and over 1. Okay, how do you get the inverse function? Well, we had a little rule, right? You swap y and x, so instead of y is 5x, you write x is 5y, and then you solve for y, divide both sides by 5, or multiply by 1/5, means the same thing. So here's our inverse function. It's 1/5 of y, and we usually use the special inverse function notation. Whoops, 1/5 of x. That's what I have written there. 1/5 of x, 1/5 of x. Okay, I was just sort of jumping ahead of myself. What I want to do is look at some ordered pairs over here. If x is 0, let's see, y would be 1/5 of 0. If x is 1, you put 1 right there. This is yuck. So I don't want that. How about x is 5? That sort of looks nice. You put x is 5 right there. 1/5 of 5 is 1. 10 is a nice number to put in. 1/5 of 10 is 2. And if we just notice these ordered pairs, the original function had these x's and y's. And what we've done is we swapped them. And now the x's became y's and the y's became x's. And here's the graph of the new guy. Let's see, 0, 0 still there, but now we have 5, 2, 3, 4, 5, 1, and 6, 7, 8, 9, 10, 2. So we're up here. So there we go. And these would be the inverse points. Okay, so there's a function and its inverse. And make sure you know how to write exponentials to logs and logs to exponents. At any rate, happy studying. Let me stop this here. This runs about 13 minutes.